Next one is the very important signal, impulse function. The impulse function is a mathematical signal. Practically, true impulse function won't exist. Why you see? We know that this is a pulse of width delta. Height is 1 by delta. 1 by delta. Energy content is proportional to this area. If this area remains constant, energy remains constant, area is constant. For that, if you decrease delta, what will happen? If you decrease delta, it will be like this. If you further decrease the delta, it will go like this. If you want to decrease this delta, this magnitude m will go on increases. So if delta approaches 0, as it approaches 0, m approaches infinity. M approaches infinity. The limiting value of delta tends to 0. The magnitude reaches infinity. However, the area remains 1. Let us assume that the area of this signal is 1. Area under the signal is 1. Even it approaches 0 and it approaches infinity, the area under this signal is unity. If delta approaches 0 and magnitude tends to infinity, then this rectangular pulse function tends to impulse function. So, impulse function means this width of that pulse tends to 0 and the magnitude tends to infinity, but the energy content is constant. Energy content is constant. Energy content is constant. Remains same. So impulse function means it's the energy content is example, practical example of a impulse function is hammer blow. Hammer blow. If you give me a hammer blow, then that is called the impulse function. Contact duration of that hammer and the surface on which we gave the hammer blow must approach delta t should approach 0. Very, very small. It should be very, very small. Then it becomes impulse function. So practically, this is approaching 0 is not possible. That's why it is a mathematical signal. But negligible time means it can be considered as impulse function. That's why Bruce Lee becomes famous, because the duration of contact because of his blow to the other person is very, very, very small. He is giving impulse. That's why he became famous. And all his outputs are impulses. That's why it's famous. Now I think you understand the impulse function. Impulse function means it is a pulse function, rectangular pulse function, whose width tends to 0. That's why its magnitude tends to infinity. However, the energy content in the signal is constant, remains 1. How to represent an impulse function? Impulse function A of t equal to minus infinity to plus infinity del of t dt equal to 1. Del of t equal to 1. If you integrate this entire signal from minus infinity to plus infinity, its magnitude remains 1. That is the meaning of this. Here, del of t is the impulse function. It exists only at t equal to 0. So it exists only at t equal to 0. Minus infinity to plus infinity. Del of t dt equal to 1 is the mathematical expression of the impulse function del of t. So its energy content is constant. Energy content is constant. That is very important. So how to represent a delayed impulse function? Delayed impulse function del of t minus a, del of t minus a. Here also it minus infinity to plus infinity, del of t minus a dt equal to 1. So it will exist when del of this index must be 0. When it will be 0? When t equal to a. When function will exist at when t when this index becomes 0, when t equal to a. Therefore, it is a delayed impulse function. Delayed impulse function. How to represent the delayed impulse function? Impulse function is represented by this. If a impulse function is represented at t equal to 0, this is impulse function represented t equal to a. Now, let us see the properties of this important impulse function.